Hey guys, welcome to Safi Mixed. In this video, I will let you know about the procedure how to find the equation of a tangent line to a curve. With this aim, I first draw a curve like this, and as obvious from its shape, it is a parabola where I take the x coordinate along horizontal and the y coordinate along vertical, and the y coordinate is in fact equal to x squared. Then I take a point on the curve and I drop a perpendicular from the point and it meets at 1 along x-axis, and similarly I drop a perpendicular on y-axis and we see it meets at 1 with y-axis. That means the coordinate of this point are 1, 1. And then I want to find the equation of this tangent line passing through point 1, 1. But there is a problem. In order to find the equation of a line, we need to find the slope. And in order to find the slope of a line, we need the numerical values of 2 points. So now, what strategy we can follow to find the slope of this tangent line? So first I want to understand this geometrically, and I consider another point on the curve, and I denote this with point Q. Now the coordinates values of point Q are xy, but we know that y equals x squared, so I can rewrite the coordinates values in terms of x as x and x squared. And if I draw a line passing through point P in Q, it is a line of like this one. And since this line is touching the curve at 2 points, therefore it is a secant line. And by no way the slope of this secant line is equal to the slope of tangent line at point P. So what we do, what if I shift the position of the point closer to point P? That is what if I take a point like this, and now if I draw a line passing through point P in Q, this one point, then the slope of this line is getting closer to the tangent line. This gives us an insight, means if we want to find the slope of this tangent line, this red tangent line, we need to choose a point on the curve which is closer and closer to point P. For example, if I consider another point like this, and now I draw a line passing through these 2 points, then this dashed line is obviously more inclined toward the red tangent line. So if we keep on getting the point closer and closer to P, we would be able to reach the slope of the exact tangent line. Okay, that is a geometrical perspective of the line that we can do numerically, but there is another analytical way. To understand this analytically, what I do, I just write the equation of the slope of the tangent line passing through point Q and P, and that is the value of y coordinate at point P minus the value of y coordinate at point P divided by the value of x coordinate at point Q minus the value of x coordinate at point P. Now we know the values of yp and xp, which are 1, 1 as given over here. So I just replace those values into this equation and rewrite the equation into this form, and I call this equation 1. One thing more, you must note that I have replaced yq as x squared. Now let us see what happens to the value of x when we get the point Q shifted toward point P. If I take the value of x coordinates on this red point, it touches the x-axis at this position, which is a bit far away from point 1. If I drop a perpendicular from this point, now the value of x coordinate at this point is getting closer to point P, and similarly if I take this one point, it is further getting closer to point P. This geometrical expression gives us an insight that if we take the limit of the slope of the secant line, with x, we will be able to get the slope of the tangent line. That is, the slope of the tangent line can be written as a limit of the slope of the secant line, where the limit is taken with respect to the x coordinate and it tends to 1. We see this from this geometrical aspect. As the value of the x coordinate for point Q is getting closer and closer to 1, we are going toward the tangent line. So I substitute the value of ms from equation 1, which is this value, and therefore I can write the equation into this form, and I call this equation 2. Now I want to simplify this fraction first, and I write this in the form x squared minus 1 divided by x minus 1. I can factorize the denominator into two terms like x plus 1 and x minus 1, and I write the denominator as it is. Now I can cancel the x minus 1 in numerator with the 1 in the denominator and can finally get x plus 1. If I substitute this value in equation 2, the slope of the tangent line becomes x plus 1, limit of x tends to 0 into x plus 1. And if I substitute the value of the limit, I get 1 plus 1 equals 2. So that means the slope of the tangent line at point P equals 2. Now, with the value of slope known to us, we can find the equation of this tangent line. For that purpose, I rewrite equation 1 into this form. That is, the slope of the tangent line equals y minus yp divided by x minus xp, where y and x are not known to us and yp and xp are known. So I write this as y minus 1 divided by x minus 1. And I can arrange this equation into this one form, where I take the denominator to this side, multiplying it with empty, and then inverting the whole equation. So I write y minus 1 is equal to empty into x minus 1. And now I put the value of empty over here, and taking the 1 to this side, it becomes plus. And then finally simplify the equation of the tangent line at point P equal to y equals 2x minus 1. So this way you can find the equation of a tangent line to a curve at a given point P. If you haven't yet subscribed to Safi Mixed, kindly support the channel by pressing the subscribe button. And hey, don't forget to hit the like button on the video. Thanks for watching.